Donald Hoffman begins the conversation by challenging the intuitive assumption that what we perceive is an accurate reflection of objective reality. Common sense teaches us that objects like cars or the moon exist independently of our perception. However, Hoffman argues that when examined through the rigorous lens of evolutionary game theory, the likelihood that organisms have evolved to perceive reality truthfully is effectively zero. This conclusion arises from the mathematical analysis of fitness payoff functions which shape evolutionary outcomes. Because these functions are unconstrained in form, and because evolution favors fitness over truth, perceptual systems are sculpted for survival advantage, not for reality's accurate representation. Hoffman highlights that while Darwin's original theory lacked formal mathematics, later developments like John Maynard Smith's evolutionary game theory enable these precise analyses. The zero probability result suggests that our sensory experience is a kind of user interface shaped to guide survival behavior rather than truth-telling. Thus, he reframes perception as a survival strategy optimized to hide the complexity of reality instead of revealing it, offering a profound pivot away from classical scientific realism. Continuing, Hoffman emphasizes a critical philosophical underpinning of science. Every scientific theory relies on assumptions and therefore possesses a limited scope. Drawing analogy to Einstein's theory of relativity, which begins with unprovable assumptions such as the constancy of the speed of light, Hoffman asserts that no theory can claim to describe all of reality exhaustively. Indeed, even the most sophisticated frameworks, quantum mechanics or general relativity included, are partial and contingent. This recognition counters the widespread misconception that science is inexorably crawling toward a final theory of everything. Instead, Hoffman stresses that great scientific theories not only define their explanatory power, but also illuminate their limitations by using their own assumptions to reflect on what they cannot explain. Darwinian evolutionary game theory, in this light, is a great theory because it points beyond itself, showing that its foundational assumptions about physical objects in spacetime do not capture the ultimate nature of reality. Hoffman then addresses the surprising variability in perceptual experience across species. While humans share many common sensory faculties, even among humans there exist variations, such as in tetrachromates, women with 4 types of color receptors who can perceive a vastly richer spectrum of colors than typical trichromats. This reveals that individual experience is not universal, but shaped by biological differences in sensory organs and neural processing. Beyond human diversity, other species perceive vastly different sensory domains. Certain birds navigate using polarized light, some aquatic creatures detect electric fields, and others sense ultraviolet or infrared radiation invisible to our eyes. Hoffman reflects on the impossibility of knowing what these non-human experiences feel like, highlighting that all perceptions are subjective constructs. This diversity underscores the central thesis that perception is not reality, but a species-specific virtual reality tailored by evolutionary pressures. Building on the theme that perception is a constructed interface, Hoffman introduces his striking metaphor of space-time itself as a headset that consciousness wears. Just as virtual reality immerses a player in a complex but ultimately synthetic environment, our space-time experience presents a simplified, encoded version of an infinitely complex underlying reality. Evolution shapes this interface to provide functional, fitness-enhancing perceptions rather than a faithful depiction of the ultimate substrate. This reframes space-time not as fundamental, but as a kind of user experience that filters and compresses reality. This perspective aligns with recent developments in physics, where high-energy theorists recognize that space-time breaks down at the Planck scale and that deeper mathematical structures lie beyond it. Hoffman emphasizes that the rules of physics emerge from the interactions of conscious agents through what he later formalizes as trace logic, and the familiar universe of space, time, and matter is a special, limited projection of this wider realm. One of the crucial issues addressed in the podcast is the long-standing observer problem in quantum mechanics. How and why the act of measurement collapses a quantum system's probabilistic state into a definite outcome. Hoffman notes that quantum theory forces us to confront the role of observers seriously. something classical physics could ignore by treating observation as a passive reveal of reality. Quantum mechanics posits unitary evolution of wave functions in the absence of measurement but discontinuous collapse upon observation, a feature that defies simple physical explanation within conventional frameworks. Hoffman points out that existing attempts to model measurement as a physical device fail because no such device modeled by the Schrödinger equation alone can cause collapse. Decoherence helps, but does not resolve the fundamental issue of how single outcomes arise. This highlights an unresolved problem that Hoffman sees as central to consciousness research and supports his view that a new conceptual foundation, where consciousness is fundamental, is needed. Hoffman critically examines contemporary physicalist approaches to consciousness, such as integrated information theory or global workspace theory, which try to map conscious experiences to particular physical substrates or causal structures in the brain. Despite considerable effort, he notes that such approaches have not produced mechanistic explanations for any specific conscious qualia, like the taste of mint, let alone the full diversity of experiential phenomena. This failure is not due to lack of talent, but reflects a fundamental problem. Consciousness cannot be constructed or derived from unconscious physical processes. Hoffman argues that the abundance of neural correlates, no matter how predictive, cannot be equated with causal genesis. He challenges physicalist researchers to present a detailed causal mathematical structure corresponding to particular experiences, a challenge they have yet to meet. This critique motivates his project of making consciousness the fundamental ontological starting point rather than an emergent property. Hoffman introduces a novel framework for mathematically modeling consciousness by treating conscious agents as Markov chains, systems with probabilistic transitions among possible conscious states. Starting from the simplest case of a traffic light's red, yellow, and green states, he extends the concept to encompass the enormous range, trillions, of possible conscious experiences. He introduces trace logic as a newly discovered mathematical structure among Markov chains that orders and relates different observers' experiences, explaining phenomena like Einstein's time dilation and length contraction as arising naturally from differences in observers' transition probabilities and counters. This logic, formalized as a partial order, governs how observers combine experiences and how their perceptions can mesh, thereby providing a rigorous bridge between subjective consciousness and the physical structure of spacetime. Delving deeper into the mathematical consequences of trace logic, Hoffman explains how notions of space and time, traditionally treated as fundamental, emerge naturally from properties of Markov chains modeling consciousness. He details how commute times between Markov states give a measure of distance, while counters measuring transitions correspond to time, with specific classes of Markov cycles reproducing Einstein's Lorentz transformations exactly. Furthermore, he identifies the entropy rate of these chains as analogous to mass, with zero entropy rate chains, N cycles, corresponding to massless particles like photons that travel at the speed of light. This framework not only reproduces established relativistic results, but also provides an explanatory foundation for why massive objects cannot reach light speed and why the speed of light is invariant, deriving these properties from the logic of consciousness transitions rather than positing them as axioms. Expanding on the connection between Markov chains and physics, Hoffman and his collaborator have shown that quantum wave functions correspond mathematically to harmonic functions arising from the long-term asymptotic behavior of these chains. In this view, quantum states do not represent fundamental reality, but are shadow descriptions, coarse-grained statistical summaries of the underlying probabilistic dynamics of conscious experiences. This interpretation provides a hidden variables theory of quantum mechanics that circumvents challenges like Bell's theorem by incorporating observer dependence and non-locality while remaining probabilistic. It unites relativity and quantum phenomena as emergent from the same deeper mathematics of conscious observer dynamics, offering a promising observer participancy approach that echoes John Wheeler's visionary ideas about information and reality. Hoffman reveals that the mathematical formalism of trace logic necessitates a universal measurable space containing all possible conscious experiences, an infinite shared source from which individual observer perspectives, Markov chains, are derived as traces. This source is timeless, fundamental, and common to all observers, akin to the mystical concept of the One, or Indra's net, in which all individual consciousnesses are interrelated reflections within an unbounded whole. Although Hoffman admits that science cannot yet describe or explain this source beyond defining its mathematical structure, he embraces its foundational role as the origin and container of all conscious experiences. This points to a radical unity underlying apparent multiplicity and resonates deeply with millennium-old spiritual insights, while simultaneously rooting these intuitions in rigorous contemporary mathematics. The reconceptualization of consciousness as primary and spacetime as a limited virtual interface has profound effects on our understanding of life and death. Hoffman suggests that life is not an emergent property of physical matter, but inherent and ubiquitous, obscured only by the limits of our spacetime headset. The challenge of defining life versus non-life disappears once seen as a difference in perceptual filters. All matter is alive in this broader reality. Death, then, becomes metaphorically the removal of a headset, signaling a transition to other modes of conscious experience beyond our present interval. While practically sobering, the framework encourages a shift in focus from clinging to transient identity and accomplishments within spacetime to appreciating the vast, ongoing journey of consciousness through innumerable perspectives. Hoffman also connects this view to the cultural and spiritual need for humility, adaptability, and compassion grounded in the recognition of shared consciousness. Toward the end of the conversation, Hoffman speculates on the transformative implications if humanity ever learns to manipulate the underlying conscious agent dynamics beyond spacetime. Analogous to a game programmer who can rewrite Grand Theft Auto internally rather than merely playing it, beings with access to these deeper structures could profoundly transcend our current technological limits, enabling interstellar travel beyond light speed, reality manipulations, and miraculous interventions currently deemed science fiction. However, Hoffman cautions that such powers would come with immense ethical responsibilities, as realizing that harming others equates to harming oneself now becomes a scientific fact rather than a moral ideal. He advocates that deeper scientific understanding, coupled with spiritual wisdom, could foster a new era marked by reverence, responsibility, and empathy, essential for humanity's survival and flourishing amid emerging powerful technologies and global challenges.